Okay, so for number 45, an arrow is shot from the height of 32 feet with initial velocity of 56 feet per second. The equation of the height, h of t in feet, of the arrow at time t in seconds is h of t equals negative 16t squared plus 56t plus 32, and you're only looking for the interval between 0 and 4. So the time you're only looking for is between 0 and 4. The best way to do this one is to put it in your calculator. So you're going to pull up your calculator and you're going to go to y equals. And you are going to put in the equation negative 16x squared plus 56, x, or t in this case, plus 32. Now if you hit zoom 6 on this graph, you will see that you really don't get a whole lot of information from the graph because it's really hard to see where the graph is. So what you're going to do is you're going to do a zoom 0, a zoom fit, and that will allow you to at least see where the vertex of the parabola is going to be. But again, you're only looking between 0 and 4. Do you really need all of this negative information? The answer is no. So what you're going to do is you're going to press your window key, and you're just going to get rid of all those negative numbers. So you're going to set for your x minimum as 0, and you're going to also set your y minimum as 0. I also like to kind of go a little bit further than what they already have the y max at. That y max is about where your vertex is, but I like to go a little bit higher, so I'm going to make that 85. If you also want to give yourself some room to do some of the functions, you can set your y min to negative 5 and your x min to negative 5, just so it goes a little bit below and a little bit to the left in order to be able to see all of those key points on the graph. So now if you press graph, you'll see that it gives you a much better graph viewing window. Notice again, it only goes up to 4 right here. So when you are looking at the graph, you can look for all of the key pieces of information. You know that since the y-intercept is, the constant here is 32, you know that that is where it's starting. That is your initial height. It's from a height of 32 feet. So it's starting at time 0 at 32 feet. It's then going up. So if you're looking at the graph like this, it's starting here at 32 feet. It's going up and it's coming back down. You will notice that on your graph as well, it's hitting the ground at 1, 2, 3, 4 seconds. So this is actually 4 seconds. And so then we can answer when letter A, which is when will the arrow hit the ground, it will hit it at 4 seconds. So you want to grid that in as a 4. For letter B, how high will the arrow be at t equals 1.5 seconds? For this, you're just going to take that value and you're going to plug it right into the equation. So negative 16 times 1.5 squared plus 56 times 1.5 plus 32. If you plug all of that in and simplify it in your calculator, you will get the value of 80. So it will be 80 feet in the air at 1.5 seconds. Finally, the maximum height the arrow will reach. For this, you're going to want to go back to your calculator. There are several ways of finding this, but in this case, you are looking for the vertex of the graph. So what you want to do is you want to use your functions on your calculator to help you find this maximum point. So you're going to press second trace, which will then give you value and 0 and minimum, maximum, intersect. You, of course, want the maximum value, which is 4, so you're going to press 4. It's going to ask you for the left bound, so you want to arrow over, and you're going to press enter for the left bound. It's then going to ask you for the right bound. Arrow over to the right side of the vertex, press enter. Press enter one more time, and it will give you that the top height is at 81, and that occurs at about 1.75 seconds. So you know that the maximum height is going to be 81 feet.